Homework for yesterday was a worksheet on constant speed and velocity. We didn't check that over yesterday because we did our lab, but we all have it done now. So we're going to check over a couple of those questions now. The ones we want to look at right now are questions 5 and 6, the last two questions on the page. We want to do this in a couple of different sets of units because some of you have done it in different ways. Some of you have done it using meters per second. Some of you have done it using kilometers per hour. The question says a jogger runs 5 kilometers north in 25 minutes, then stops for a break for 10 minutes and runs 10 kilometers south in 53 minutes. What's the jogger's average speed and the jogger's average velocity? First of all, before we look at units here, what do we got? The jogger runs 5 kilometers north. Is that a position or is that a displacement? Is that where the jogger is or is that how far the jogger's gone? Davin, you look like you want to give me an answer there. Is that position or displacement? Good, that's displacement. We're going to say the first displacement here, D1, is 5.0 kilometers. And we're going to define north as positive, so it's going to be positive 5.0. Now T1, the time interval for that 5 kilometer run is 25 minutes. D2, the second displacement, it's a displacement as well, right? Is going to be 10 kilometers, but it's to the south, so we'll make it negative, and the time there is 53 minutes. Delta T2, 53 minutes. So what do I got to do here now? To find the average speed, I'm going to say distance over time. But I don't like the whole kilometers and minutes thing, so I've got to convert one or both of them. I don't have to, actually. I could go kilometers per minute. But I want to convert one or both of them to give me more normal units. The way I did it is convert it minutes to hours. To convert minutes to hours, you're going to divide by 60 because there's 60 minutes in an hour. So you divide 25 by 60, and you end up getting 0.41667 hours. 53 minutes, 53 divided by 60 is going to give me 0.8833 hours. So you want to find the average speed. We're simply going to add the distances together. 5 plus 10 is 15 kilometers. Not 5 plus negative 10, because we're talking speed here. 5 plus 10. Divided by the total time, which is 0.416 hours, plus 0.883 hours, which gives me 1.29999 or 1.30 hours. Do the math there. 15 divided by, is that right? Here's my issue. I got a third phase. It's actually in the middle where I took a break, 10 minutes, which corresponds to 0.167. And the velocity or the displacement during that stage in the middle was 0. So the distance is still the same, 15 kilometers, but my time is no longer 1.3 hours. My time ends up being 1.4667 hours. It's the sum of all of the times put together. All right, that makes more sense. Now when I divide those, I end up getting 10.2 kilometers per hour. My average speed, no direction associated with it. Okay, that positive doesn't mean north, it just means scalar. Now my average velocity is going to be found by taking displacement divided by time. And the displacement here would be 5 plus negative 10, which gives me negative 5.0 kilometers, divided by a time here in hours of 1.467, which gives me negative 3.41 kilometers per hour, or 3.41 to the south kilometers per hour. So if you did it in kilometers, you did it in hours, this is what you should have gotten. If you did it like Aiden did it, in meters per second, you're going to get different numbers, right? So let's take a look at it now using the units that Aiden used, and that's probably some of the rest of you used as well. We've got our same givens now, but we want to convert differently. Instead of converting minutes to hours, we're going to convert minutes to seconds. 10 minutes would be 600 seconds. 25 minutes would be, well, 25 times 60, whatever that works out to be, 1,500 seconds. 53 minutes, multiply that by 60, and you end up getting 3,180 seconds. But if we're going to go to seconds, we probably should go to meters as well. 5 kilometers is 5,000 meters, right? Multiply 5 by 1,000 to get 5,000 meters. Negative 10 kilometers is negative 10,000 meters. So now when we want to find the average speed, we're going to go distance over time again, but the distance we're going to list in meters. It's going to be 15,000 meters. We're not paying any attention to the negative in front of the 10,000. Divided by the time here, what would it be? 600 plus 1,500 plus 3,180. Ends up giving me 5,280 seconds. 15,000 divided by 5,280 ends up giving me 2.84 meters per second. Is that what you got, Aiden? How many other people did it using meters per second? Okay, 2.84 meters per second. Listen, I told you guys, if in doubt, go meters per second, right? Kilometers per hour is just fine for this question. But if you're not sure what you should do, go meters per second. All right, let's try velocity. It's displacement divided by time. Displacement this time would be negative 5,000 meters, and the time would be exactly the same, 5,280. So we get 5,000 divided by 5,280 gives me 0.947, negative 0.947, right? Did you get that? All right. What if I didn't want to show you this method that we just showed to validate that Aiden and a number of other people get the right answer with meters per second? What if I didn't want to go through that again? I showed it in kilometers per hour, but I don't want to go through that process again in meters per second. How can Aiden check his numbers then? Well, he'd have to be able to convert kilometers per hour, the answers that I gave you, to meters per second. Let me show you a little trick to do that. Let's say you have a speed of 90 kilometers per hour, or whatever. Let's convert that to meters per second. First, actually, before we do that, let's convert 90 kilometers to meters. How many meters in 90 kilometers? How do you figure that out? That's not a crazy hard calculation, right? You guys all know this. How do you convert 90 kilometers to meters? Yep. Times by 1,000. So 90 kilometers equals 90,000 meters. Everybody agree with that? Nothing crazy hard about that, right? What about 1 hour? How many seconds is that? Well, there's 60 seconds in a minute and 60 minutes in an hour. So if you multiply 1 hour by 60, you get minutes. You multiply by 60 again, you get seconds. So it turns out when you do that, 60 times 60, you end up getting 3,600 seconds. So 90 kilometers is 90,000 meters. 1 hour is 3,600 seconds. Here's what I want to do in converting kilometers per hour to meters per second. I want to convert 90 kilometers to meters, and I want to convert 1 hour, because that's what I got on the bottom, right? 1 hour to seconds. How do I do that? 90 kilometers is equal to 90,000 meters. 1 hour is equal to 3,600 seconds. So all I'm doing is replacing 90 kilometers with 90,000 meters, and I'm replacing 1 hour with 3,600 seconds. Divide those. And when you divide those, you're going to end up getting 25 meters over seconds. Does that make sense? So how do you convert kilometers per hour to meters per second? Convert kilometers to meters, and then convert hours to seconds. Multiply by 1,000, and then divide by 3,600 every single time. Okay, that's something that's going to pop up fairly often, actually. You're going to have to do that conversion of kilometers per hour to meters per second. Right now, when we're dealing with just speed and velocity, you can get away with using kilometers per hour, as we did on this worksheet. But when we start dealing with acceleration next week, we're going to sometimes have to be in meters per second. So sometimes when you're given kilometers per hour for a speed, we're going to have to get into meters per second, like a number of you guys did for these questions. All right, next question we had to do was number 6, I think. And that was a meters per second thing as well, right? So let's do that in kilometers per hour, and then we'll use our conversion that we just learned to check our answers for meters per second for that one, okay? So 6 says a car travels 90 kilometers per hour east for 10 minutes, then goes 100 kilometers per hour west for 30 minutes. What's the average speed and velocity? Similar to the last question in the sense that we got to find speed and velocity, 2 stages. Different in the sense that we're not given the distance or displacement for each stage. We got to find it. Let's write down some givens here. In the first stage, we're going to say the velocity is 90 kilometers per hour. And the time is 10 minutes. In the second stage, we're going to say the velocity is negative 100 kilometers per hour. And the time is 30 minutes. Now, in order to get the numbers to plug into this equation, we got to get this number, distance or displacement. So let's take these 2 numbers, use a rearranged form of V equals D over T, and find the displacement in each stage. So here we'd say the velocity is 90 kilometers per hour. 10 minutes, by the way, converted to hours, would be 0.167 hours. We divide by 60, right? 10 minutes divided by 60. And when you do that math, it gives me 15 kilometers. In the second stage, we're going to say the displacement is negative 100 times 0.5 hours, which gives me negative 50 kilometers. Now, when we want to find the overall average speed, we're going to say distance over time here. The distance would be 65 kilometers, because we're not paying attention to direction here for distance. Distance is a scalar, divided by the time of, what do we got, 40 minutes, which is 0.6667 hours, which gives me a speed of 97 kilometers per hour. Now we want to find the average velocity. It's going to be displacement over time. The displacement here would be 15 plus negative 50. Add them up, but add one up as a negative value. Gives me negative 35 kilometers. 0.667 hours. Gives me a velocity of negative 52. Is that good? How many people that did it in kilometers per hour got that? Okay, if you did it in meters per second, you're going to get different numbers, right? So let's check this using the technique that we just learned a minute ago to see if you got the right answer in meters per second. 97 kilometers per hour. What do we get? 97 and 52? .97 kilometers per hour. By rights, I actually should be using the unrounded number here, right, as opposed to the rounded number. So my number could work out to be slightly different than yours in meters per second, because I don't know what the unrounded number is. I didn't write that down. But you'll see if you did it right. 97,000 meters divided by 1 hour is 3,600 seconds. 97,000 divided by 3,600 gives me 26.9 meters per second. How many people got that? All right, the last one here, we got 52 kilometers per hour, or negative 52 kilometers per hour, is negative 52,000 meters divided by, well, 1 hour is 3,600 seconds. Gives me negative 14.4 meters per second, or 14.4 meters per second to the west. Good? Guys comfortable with that? Comfortable enough to have a little quiz on that on Monday? Yes?